So what I'm going to talk about is obviously introduce the topic of coastal hazards that impacts our region. And I think everyone on this call probably is well aware that the Pacific Northwest is really exposed to many different types of coastal hazards. These range from obviously extreme winter storms that produce large waves, and the results of those large waves eventually expend themselves on our beaches, contributing to issues regarding coastal erosion, damage to infrastructure and properties and so on, as well as obviously affecting flood within our lower lying areas, particularly in estuaries and adjacent to ports and harbors. So one of the most, or really the most catastrophic hazard that the NANOOS region is exposed to is related to the potential Cascadia subduction zone event rupturing sometime either today or into the future, preferably not today. But the potential for it to unleash a catastrophic tsunami along the region that will obviously affect the NANOOS region as a whole, but also extending down into California, up into British Columbia, and then across the Pacific Basin. And the best analogy for this is only to look at what happened in 2011 on March 11th, when the Japanese earthquake, a magnitude 9.2, ruptured over there, producing a catastrophic tsunami locally on the Japanese coast and resulting in about 18,500 casualties. These are the same risks that the Pacific Northwest region are exposed to. Next slide. So to address this hazard, and beginning in about 2010, when I was part of a pilot team with NANOOS, one of the things we were endeavoring to do was to actually integrate various evacuation map products that have been developed by the Geologic Survey in both Oregon and Washington State, and be able to portray that information in a graphical form that may be accessible by the broader public. And so that really was the initial sort of starting point for the NANOOS Tsunami Evacuation web app and portal. And so obviously the goals behind developing this particular tool was really revolving around allowing people to pre-plan for a major event, be it a distant event that might occur, say, up in Alaska, or as an example, the most recent event that took place down in Tonga that triggered a Pacific Basin-wide tsunami. So this tool provides the mechanism for emergency managers to respond, for the public at large to pre-plan where they're traveling along the coast. So the underlying elements that make up this tool include evacuation maps that provide an individual with a clear indication whether they're in a particular zone, a tsunami hazard zone or not, identifying areas of safety as shown in this particular image here by the green zone, or if there are vertical evacuation structures that may be located within an inundation zone, as has been recently built at the Hatfield Marine Science Center down here in Newport, but also at the Acosta Elementary School up in Washington State. The other sort of critical element behind this tool was obviously to begin to integrate warning information for distant events that are generated by the National Tsunami Program through the Tsunami Warning Center that's based out of Palmer, Alaska. And so these two capabilities have really been sort of the foundation for the tsunami evac going forward. Next slide. The last element of the tool has been really to try to assist people who may be visiting the coast. They can figure out whether they're in a tsunami zone by either clicking on the map, or they can actually enter a physical address of a house that may be visiting or staying in, a hotel, etc. as a means for pre-planning where the inundation zone is, and importantly, to begin to figure out how to get out of the inundation zone to reach safety. And so one of the most recent developments that we've been able to implement through a collaboration of ourselves with the Oregon Department of Geology, but also the University of Oregon, and then NANOOS as the underlying software engineering aspect of this, being able to integrate all these different data fields and be able to produce on-the-fly, real-time routing that the public can use. And so obviously, this is an example of downtown Seaside on the northern Oregon coast, probably one of the potentially one of the most significantly impacted areas of the coast. So I'm going to stop there and I'll turn it over to a couple of colleagues who I work very closely with. If you could move to the next slide, Lee Hiltenbrand from the Nehalem Emergency Volunteer Group, who's going to speak to how they use the tsunami evacuation portal from NANOOS.
Great, thank you, Jonathan. And I really want to extend a thank you to NANOOS for inviting us to participate. This is a fantastic workshop already. I find myself preoccupied with Mark's talk about the ocean waters because I know very little about that. So it was a quick education. But we're here today to talk to you a little bit about how we use the structure that's been created by the sorted folks that Jonathan mentioned as helping develop these programs. I'm here today with my colleague, Linda Koslowski, who is with the founder of the Emergency Volunteer Corps of Nehalem Bay, as well as one of the longest serving officers in the organization. But we are not scientists. I want to reiterate that. We're not government officials. Rather, we're users of NVS and how it best helps us keep our people safe and make them aware of opportunities to avoid hazard. Think back 20 years ago, somebody said something about a big one happening, and what do? Well, you go to high ground. But there's a lot of questions associated with that. Number one is who? Do I need to go to high ground? Am I in a vulnerable situation? When? Is it immediately after the event happens, or do I wait until I see water rising around me before I move? And where do I go? Do I just go to high ground? But how high? There's no markers, there's no delineation on the streets or, as you traverse through the forest or fields to get to what you know as a safe place of refuge. So next slide, please. And Nick, I got to tell you, it's really nice having you do this. I usually have to do it myself when I'm involved in one of these, and it can be kind of awkward. So I appreciate you being there today. So, early on, there was a lot of signage that was being produced by governmental agencies, cities, counties, states. And these signs were posted along various streets and avenues and highways to make us aware that we were either in or out of an inundation zone. That's great, that's a start. But then these maps, like is shown here, came out, I'm thinking about 10 or 12 years ago when these maps were first produced. And they provided an early glimpse of which direction do I go? Where do I have to evacuate to? And so you can see the areas are defined by 3 different colors, orange being a distance tsunami effect, yellow being a Cascadia event off the coast, and green being a place of refuge or safe harbor. Along with that, you see that there's some other symbols on there. The A is representative of what we refer to as a assembly area. I'm not certain if that's consistent with DNR in Washington, but this is an Oregon operation. We utilize these frequently up until about 3 or 4 years ago when we had some new developments. But what this did show was it provided directional paths. It did not show the hazards that one might encounter, i.e., is this bridge likely to fail or not? Or is it going to be serviceable after a big one? These mapping details were also static. You had to review a lot of maps in order to take care of your needs regardless of where you traveled. And I think being prepared early on meant that you had to have a back seat full of maps as you traversed the coast. Not really the best way to do things, but it was what we had available, and it was better than previous. Can you go to the next slide, please? Thank you. So a few years ago, these were what we refer to as beat the wave maps. And these provided a lot of additional information, i.e. a starting point, not particular point, but an idea of where you were at the time that the event occurred. And most importantly, as you can see on the chart here, and it's defined over on the right side, to get to a point of refuge at a walk speed, a jog speed, or a sprint speed. So obviously the farther you were away from the point of refuge, you had to increase your speed in order to get there. And this was really critical, especially in our aging communities down here on the coast. It afforded them an opportunity to help determine when they were going to have to leave compared to the time that the event happened. And we know now from scientific data that the most important thing you can do is leave immediately after the ground stops shaking. But, you know, with people being being disabled or otherwise compromised, it was important to know the speed that they had to utilize in order to get to a place of safe refuge. And you'll notice up in the top of this map, there's a insignia, the circle with a slash through it, bridge failure. It's an indication that that bridge is not likely to survive a seismic event. So that was also extremely valuable information. What these maps did not do is they did not provide a specific path. They gave you an idea, but it wasn't real specific. It gave you an area, if you will, that you needed to traverse and some general direction on how to get there. Next slide, please. So this is the map that Jonathan alluded to a while ago. He had a lot more information on there. I'm going to kind of go through the different informational elements. And this is what is now on the NANOOS portal. We're very, very excited and happy to be able to use this tool. It provides an opportunity for tabbed locations for future use. So you can store an abundance of these starting points, i.e. place where you work, place where you visit, a place where schools, medical facilities that you might go into on a regular basis, they're all there for you to use in the future as far as a means of escape and a place of refuge. And you'll notice that on the right-hand side there's some specifics about mapping details. So you see an address there, 90 Portland Avenue, Manzanita. That's the blue square with the yellow outline down at the bottom of the page. And it automatically putting in that address provided a dotted map to get to a place of refuge. In this case, the exit location is listed on the evacuation route as 275 Ocean Avenue. It's a total distance of 1,021 horizontal feet with a walking time of 7 minutes. Excuse me, 7 minutes, and that's at a pace of 32.3 minutes per mile. So that's a pretty good pace. On the other hand, if you run, you could get there in 3 minutes. So there's a lot of information provided here. This is the first time that we actually had, it allowed us for a decreased response time. It provided us with real-time decision-making on most of the Oregon coast. I say most because there's still some islands that are not mapped. There's some specific locations in some of the regions that are mapped there's some specific locations that are not yet mapped. So I'm going to talk about that in a minute, because I think there are some potentials to increase the value of this program going forward. This tool does save lives when people are aware. I think that the biggest hurdle that NANOOS has, and all of us who are involved with emergency preparedness, the biggest difficulty and hurdle that we have is awareness. And how do you increase that? I know that was one of the questions that was hoping to get some attention today. Next slide, please. So we don't have any more slides. I'm just going to, you're going to have to look at my mug, and while I tell you that, maybe you should go back to the slide. That doesn't look very good, Nick. Thank you. So you might ask, how many of the coastal residents are using this portal? Many are not. And the question is why? I think that, again, increased awareness is critical to using this tool on a broad basis. We have approached our city council here in Manzanita, and they have been receptive to and will likely be posting the link to the NVS portal on the city website. And I would encourage all of you to reach out to your community leaders and see if that isn't some avenue that we can all take to as a means of providing access. I think that we get lost sometimes with all of the opportunities to share this information, and we just think that because we know it, other people know, and that's definitely not the case. So tourists and visitors are even less tuned into the benefits. I don't know what the answer is for that. I have some thoughts and some suggestions. Here at the coast, our population swells to 5 times the resident population in the summer on any given day. So that's a lot of people who, they may be aware of earthquakes, but if they live in a valley someplace, they're not necessarily aware of tsunamis. You know, you'd think that 2011 in Tohoku would be an eye-opener for everybody, but for some reason we tend to forget those kind of things soon, move on. But here's some suggestions for increased awareness. I think that NANOOS and the developers of these portals need to assume that there are many first-time users, and they need to reach those folks. It's a question of how do you attract folks to the site. Perhaps some media platforms that haven't currently been used to attract younger readers and listeners, and urge all communities again to post that NVS link on their websites. There's an opportunity to put literature and postings in visitor centers, chambers of commerce. And I got to thinking about how many of us visit motels and hotels. And while the younger generation tends to be electronic, some of us older folks tend to kind of be attracted to those kiosks with all the maps and the wine country tours and balloon tours, etc. That might be a good place to consider some kind of media copy of the NANOOS portal and its capabilities after or before a tsunami, so that people know how to get to the link. There are still some islands that exist in the mapping, as I mentioned earlier. I'm hoping that future efforts to improve the portal will include some of those areas. And I'll give you a couple of examples. There's a large Fred Meyer store in a North Coast community that has no evacuation mapping. There's a hospital in Seaside that has no evacuation mapping. So those are areas that are prone to large concentrations of people that would benefit from knowing where to go when they leave the door. Again, the larger issue is education and awareness. Another thought that I had was that existing tsunami signage the signage that says, caution tsunami zone, or you're leaving an inundation area or entering. Those could be retrofitted with a decal that suggests links to the NBS portal. And new signage, whenever signs are replaced, they could also include that language of having an NBS link. So with that, I'm going to turn it back to whoever's going to take the mic. Thank you.
Thanks, Lee. That was fantastic. I really appreciate the work you guys are doing in Manzanita, both you and Linda, and the time for you guys to come here and present to us, and your insights. I mean, that was really valuable. We appreciate that very much. So thanks again, Lee. So we're going to move on, and I'm sure that this will allow for some of these suggestions here, will allow for some very rich discussions later on when we do our breakouts. So I appreciate some of the initial suggestions there as well, Lee. It's my pleasure to introduce Rachel, who's going to talk about the